Hello and welcome to today's webinar entitled The Key to Unlocking the Economic Value of Fast Data in the Cloud. My name is Peter Viscuso. I'm with VoltDB and I'll be the moderator for today. I'd like to let you know a few things before we get going, a couple of housekeeping items. It's a live presentation through On24. There's a large number of people on the call and we're going to have the lines muted, but we'll encourage you to ask questions through the chat window that's available on the On24 interface. The presentation will go approximately 45 minutes and we'll have time for questions at the end, and we do encourage you to ask questions. There'll be an archived version of this presentation available in a few days, and we'll send everybody that's registered and attending a link to the replay and a copy of the slides. The phone lines will be muted, as I said, so please use the chat window to ask questions. Now let me introduce our speakers. We're happy to have with us today Mac Devine, who's Director of CloudFirst Innovation and CTO of IBM Cloud Services Division. Mac has 24 years experience in networking and virtualization, and in his career he's led innovation efforts within IBM. He's been an IBM Distinguished Engineer, Master Inventor, member of the IBM Academy of Technology. Mac was recently asked to join the faculty of the Cloud and Internet of Things Expos and currently serves as the CTO of IBM's Cloud Services Division, which acquired SoftLayer under Mac's leadership. And from VoltDB, we have Scott Jarr. Scott's co-founder and chief strategy officer at VoltDB. He's got a bunch of experience building, launching, and growing high-tech companies. First job was writing communication software, and in that position he wrote a product called VoltDS. He's the co-founder of VoltDB, and prior to Volt was a key member of the executive team at the SaaS pioneer LiveVolt. And so with that, let me quickly cover today's agenda. We're going to start off with an introduction from Mac talking about the changing data-driven world. Then we'll hear from Scott talking about fast data challenges and architecture. Back to Mac to talk about why the cloud, specifically SoftLayer and fast data. And at the end, Scott Jarr is going to review some pretty exciting benchmark results that we have on SoftLayer running the Yahoo Cloud Services benchmark, and we'll do Q&A at the end. So with that, I'm going to turn it over to Mac Devine.
All right, thank you very much, Peter. So when you talk about IBM's Smarter Planet initiative that we kicked off about 8 years ago, we see a lot of market dynamics today that are really starting to make that vision become a reality. You have more than ever before this explosion of mobile devices, and we think that's going to go to a completely new level when you start talking about Internet of Things. And with that explosion of mobile devices and things like embedded sensors, there comes a need to have the ability to get insight and get that insight much more quickly than ever before. When you are dealing with a mobile user, or you're dealing with an embedded sensor, say in the healthcare equipment and others, moving from a kind of a batch orientation from an analytics standpoint to a more predictive real-time analytics model where you have the full capabilities in terms of ensuring the security of your data along with that real-time element end-to-end between the mobile edge and the back-end services. This aspect of being able to collect data from a wide variety of places but be able to get the insight and discover the value from that data much more quickly than ever before, those are the forces that are really driving our large enterprise customers and even SaaS companies that are born on the web to needing to have the ability to get more value out of the data and to get it much more quickly. The other thing that we see happening is really becoming a data-driven world. It's no longer just a challenge to connect to the data sources inside the enterprise, but also to connect to data sources from a myriad of places, both inside and outside the enterprise. And the key there is to be able to do so at the speed of business. I used to say when I was doing presentations that cloud enabled companies to be developed and grow very rapidly because they didn't have the impact of having to manage the data center environments themselves. So, established vendors in a space could be taken out pretty easily by, two guys in a garage. And then one of the presentations I was doing, somebody in the audience raised hands and says, "You don't need a garage." And that's true. You don't need a garage anymore. But it is a data-driven world. I mean, the companies that can use data and to get to business insight more quickly than their competition are the ones that are going to be successful. So this kind of set the stage for what we're going to go through today in terms of the value of getting insight from data very, very quickly, this aspect of fast data. And so I'm going to turn this over to Scott so he can take you through the fast data implementations that Volt is doing.
That's great. Thanks, Mac. I can't think of an organization or a person that is a better introduction into this changing world that's becoming faster and more sensorized and more automated than you and IBM. So we're thrilled to have you here, and I really appreciate that.
All right, thanks.
So I did want to talk a little bit about what this whole fast world looks like and what we mean by it. It's a word that's being bandied about nearly as much as big data at this point in time. And I love this little illustration here because I think it's indicative of what we think about when we kind of today and over the past 5 years have thought about, the challenges associated with big data. This is my favorite recommendation engine, right? This is a classic example of what we think of when we look back at historic data, get insight from that, and then try to present that to a user as they're experiencing our product. In this case, it's a funny joke on the fact that she's at a shopping center. But the idea is that they've used a tremendous amount of data in the background to build this insight that says when people buy one product, bananas in this case, they've also bought these things. But what this sort of fails to acknowledge and accept is the speed at which data is now being generated and the speed at which these decisions really make a lot of sense. So there's no insight and context to what this lady is experiencing in her shopping here around what she's doing. The idea of this automation and this recommendation engine is built on data that was collected maybe over the past several weeks or months, and it was aggregated at one point in time, and now it's being presented to everybody. So the next person that walks up after her will see the exact same recommendation based on the bananas. And what that fails to acknowledge, again, is that there's context here. There's real-time interaction that we're really starting to miss and is becoming much more valuable for businesses to take advantage of if you can harness that. So with that, I think, it almost seems odd to say this, but I think we're starting to see a lot of shape taking form in the analytics stack. There's tremendous amount of great products over here. IBM has an entire portfolio of wonderful products that are in this area. But what we're really starting to see is this data lake, this data reservoir, call it what you want. It's a large storage repository that's accepting all the data of the organization. We have some traditional apps that are starting to feed into that. But the interesting part on the big data side that I want to speak to briefly here is that this data lake exists to be the master repository of all data within the organization. Now we're going to take that data and we're going to do other things with it. We're going to run BI reporting type algorithms and products against that data. We're going to run interfaces that look like SQL so that we can gain insight into that data and present it to users in a fashion that is common and is familiar. We're going to use that data to do exploratory analytics. We're going to use products like Mahout and MapReduce to do deep data science. And we're going to do all these things so that we can gain insight into the data. But again, this is really looking at things from sort of this post-processing world. We've had apps, they've run, they've created data, we've put it somewhere, and now we're going to analyze it. But when we ask ourselves, why do we do this? What is the point of running these analytics? It's pretty obvious, right? We want to do better interactions with customers, better decisions or personalizations or fraud detections or many things that we can do with these analytics that drive tremendous value within an organization. But really the question then becomes is how do we take that stuff and not do it as a purely historical process? Because if we think about this whole data disruption that's occurring in the world, and we think about it purely from the we're going to do analytics and then we'll do something on it later on perspective, what we miss the real opportunity. And the real opportunity is all the things that Mac talked about in the beginning. It's the fact that we're seeing sensors on everything, the mobile wave, the SaaS environment. There's just a tremendous amount of opportunities that really have a real-time interaction. And then how do we start to really think about that real-time interaction at the same time that we're thinking about analytics? And that's where it starts to become a brave new world, right? I love this little picture here. It does seem crazy and ambitious and somewhat delusional, because we took things that were complex applications and we took analytics that were complex and deep, evolved applications to do that. And now what we're starting to see is people saying, I can't have these things separated anymore. From this point forward, now I have to start building applications day one with the idea that I'm interacting with data that's moving at extraordinarily high rates. I've got to make decisions on that data in real time, and I've got to somehow have that linked into the analytics that my organization is able to take advantage of to build knowledge, to build greater value for my customers, to build greater value for my shareholders, and just build a more pervasive application that is much more engaging and much more interesting for a user to use. So if we take that as sort of the basis that applications now are going to exist that need to deal with this high velocity data coming in, and every one of those sources that Mac mentioned in the beginning, make no mistake, those are high velocity sources. We have customers that are ingesting millions of events per second and trying to deal with that. So if you take those types of applications and then you take the idea of analytics, how do you start to rationalize what you need to do in both sides of this? There's the big data that we talked about, that stack before, and now there's also a fast data side that we're going to talk about here in a moment. But if we look at the requirements around fast data, they're uniquely different than the requirements around big data. And intuitively, that makes sense to us. But I'll tell you that my co-founder at Volt, Mike Stonebreaker, has been really building this thesis over the past 20 years. And what we have seen, without a doubt, is that databases have moved from a one-size-fits-all to specialization of workloads. So now when we're looking at an architecture that's doing this real-time fast data, it needs to do these things. And it's quite simple, right? Again, intuitive. I need to ingest huge amounts of data, whether it's hundreds of thousands or tens of thousands or millions of events per second. I'm ingesting these events. I need to make decisions on those. And those decisions are much stronger, much more powerful, much more valuable if I can use data, previous data, static data, current data, some historic data, to make decisions on each one of those events that's coming in. And then the third piece of this puzzle is that analytics provides visibility. And then that analytics on real-time data really takes two forms. It takes the form of how do I present something to a human, but I think also more interesting maybe is how do I use those analytics to drive that data-driven decision in the previous bullet. So I've got this system that's very simply doing these things on fast data. And when we used to talk in the olden days about doing 10 or 100 events per minute, no problem. Traditional database works fine. But that's not the world we live in anymore. And the world that we see in the fast and smart world is much faster, and it requires these capabilities in order to serve the customer needs. So it sort of drives us to this question, as I mentioned, one database isn't going to solve this problem. And in that previous analytics stack drawing that I had, there wasn't one database in there. You have lots of tools to solve this problem. But architecture is important, and as we start to look at big versus fast, architecture becomes fundamentally important. So let's take a quick look at what we mean when we think about what this fast data side looks like and how it sort of fits into the future of what a corporate data architecture is going to be. So again, we have the big data that we talked about before in our old enterprise apps, which will eventually migrate in above here into fast applications for various reasons. But if you take the things that I mentioned earlier, the ingest, the making decisions in real time, and the real-time analytics, and then glue that in a very tight way to the big data architecture, what you start to see is the capabilities to have an end-to-end data pipeline in an enterprise. So all these little arrows on the left side, those black lines, those are my feeds coming in. They're mobile devices, they're sensors, they're interactions on websites, they're web clicks, they're IP packets, they're telco packets. They're all the things that exist in all the industries that we see out there. And believe me, it's not relegated to one or two industries. This is a very broad trend. But you're taking those in, you're doing these events with them, you're pre-processing this data, you're interacting on it in real time in the user space. And then at some point we're going to move that data off into the data lake and then do all those wonderful things that we talked about in the beginning with it. But this becomes an integrated data pipeline that allows us to really take advantage of the data, both in its fast state as well as in its big state. And the thing that I'll mention here is this, is if you look at the capabilities there that we just talked about, this ingest and decision, real-time analytics and export, that closely matches an operational database. That is the kind of functionality that we expect out of a database. The problem is that in the past, we haven't seen databases that could operate at the speeds required to be fast data tools for us. So now that we're sitting here today and saying these are the requirements, fast data is going to be ubiquitous within the world and the industries, then how do we solve this problem? And I'm telling you that to do these things, a fast operational database is the way to do that. That is, in fact, what VoltDB is a fast operational database. So again, just delving a little bit deeper here, I've mentioned all of these things. They're written here so that you can look at them written form as well as review them later. But these are the capabilities. These 5 things are really the capabilities and the requirements we have if we're going to deal with fast data in real time. And the reason I list these out here is because I want to contrast this solution to something that I see in the market. A lot of customers that I talk to today when they're coming to me and saying, we've got these fast data challenges. We have to deal with these inbound feeds that are streaming in at us at unreasonable rates. How do I deal with this? And they say, well, we're going to at least try stream processing. That's sort of our first thought. So when people think of fast inbound feeds, they think stream processing. Well, I want to contrast this picture where we've solved this problem quite simply with an operational database with this next slide here where we start to say, okay, so if I'm going to do this with stream processing, and you pick your favorite tool out there, there's a lot of them because it's not, quite frankly, that difficult of technology to build. So there's lots of tools out there. So how am I going to deal with this with stream processing? Well, your first thing is stream processing does pretty good at ingesting events. And as long as there's no data involved, it can make some manipulations on that event and send it off into the big data side of the world. That all works fairly well. But as soon as you start to want to do more with that, you want to get context on that data from real-time analytics. Well, now you're writing complex algorithms to try and keep that running state, continuous computations to build real-time analytics. You're going to look at that data and constantly try to augment these analytics, and that's a whole bunch of handwritten code, and that's sort of separated from your stream processing engine. And now all of a sudden you get the real-time analytics. But you're really unable to do any decision-making that's based on data within this environment. So now you got to add a traditional database. Well, that database isn't fast enough to deal with the stream workload, which is why you added the stream processing in the beginning. So now you've added yet another piece of technology here, and you're much more filtered in the data that's going to that. So then the third piece is now if we're going to make any decisions based on that and feed that back into the stream processing system, it's really almost back to Our Lady in the shopping cart, right? Because it's aggregated data. It's filtered data. It's some sampling of the data. It's not making data-driven events on each event that's coming in. So not only have we lost a lot of functionality here, but we've also created a very complex system that has many moving parts that are kind of all glued together with a tremendous amount of code that the user has to write for it. So this is why, and we're starting to see some of these solutions showing up in some cloud platforms as the quote-unquote answer to big data. And I'm here to tell you that this is a very complex way of doing it. And unfortunately, you're not getting the capabilities that you need. And the people that have gone down these paths are quickly moving to operational databases to solve this problem. But I think that the more interesting thing is that we're seeing a lot of this show up in the cloud. And we're seeing large vendors bringing out systems that are starting to try to address this fast data problem, and they're all cloud-based systems. And that's why Volt and IBM have partnered on fast data and the cloud and the SoftLayer cloud in particular, because of the capabilities we're able to get out of the performance that SoftLayer brings to the party here. So with that and moving to the cloud side of it, I want to hand it back to Max so that he can talk some about why the cloud, and we can move into some of the benchmarks.
Yeah, thanks, Scott. So as we both Scott and I, both throughout, you hear us talking about the speed at which business is moving. And this need for cloud speed is really kind of two-dimensional. Line of business executives want to make decisions faster. They want to take advantage of the fact that people are walking around with more processing power in their mobile phones than it took, NASA to send a man to the moon in the 60s. They want to take advantage of that power that people have. Also, there's been a cultural shift in terms of the mobile phone has caused customers, to want an answer much more quickly than ever before. Is there an app for that kind of generation? We're in full throttle right now in that. People, when they have a problem, the first thing they many times do is pull out their mobile phone and look if there's an app for a solution to that. And so developers are trying to deliver applications that can meet that kind of expectation in terms of the speed at which value can be provided, and business owners or business executives in our large enterprise shops are trying to do the same thing. It was very interesting. I spoke at a conference last year. It was a business API conference, and when I got on stage, it was a classic, kind of two-sectioned auditorium with an aisle down the middle. And on the left, there were people in sports coats, and a couple of them had suits, a couple of them had ties. Very well-dressed, business casual kind of crowd, if you will. And then the other side was blue jeans and T-shirts. All right. So what did the APIs attract? They attracted developers and they attracted business owners. It's very true here in terms of fast data as well. Developers want to be able to provide value in their applications more quickly, especially if they're delivering those applications to mobile users. And business owners want the same thing. And so, the typical way we did IT was just not working. It could not meet the speed of business here. And that's why you see all these solutions, as Scott mentioned, on the cloud, because they can tap into the infinite capacity that the cloud can provide and can tap into that reach. And so, I like the quote that Albert Einstein has, says, you always do what you always did, then you always get what you always got. And so the traditional way of doing kind of batch-oriented data processing and analytics in a more of a batch fashion is not keeping up with the speed at which business needs to move today. And the other thing that's a dynamic that's often overlooked here, with the cloud-based model, you don't have to be afraid to make mistakes. You just have to be afraid not to learn from them. Business owners want to explore new areas. They're not absolutely convinced that a particular area is going to take off. They want to be able to explore the market, get understanding of the market by that exploration, and then incorporate that into the next thing. Everything was built for a slow failure or a slow success in the previous way we did IT, and that just doesn't cut it in today's world. So when you look at SoftLayer in particular, this is one of the things that was particularly attractive about the SoftLayer asset for IBM. As was mentioned in my in the bio that Peter read, I led the technical due diligence for the SoftLayer acquisition. And one of the reasons why I chose SoftLayer as the right target for IBM was that fundamentally SoftLayer had a different philosophy. If you look at the cloud service providers, they all tend to have a singular model, virtual share everything kind of model that they give their users, their customers, the ability through APIs to get to infrastructure as a service. SoftLayer supports that model, but SoftLayer also says, well, wait a minute. There are certain workloads that if I can provide bare metal infrastructure with the same elasticity and consumability and cost characteristics that I can provide virtual shared, and I can provide a dedicated environment for these high I/O intensive workloads, then I still have the flexibility and the agility that cloud has for solutions, but I also can have a higher quality of experience, a higher quality of service. And this really shone through when you talk about big data and fast data, that performance and consistent performance. When I am a customer of SoftLayer, I can have a dedicated environment on bare metal that's dedicated to me. So, if my neighbor is, that I was sharing infrastructure with is doing something that's very I/O intensive, it impacted me as a kind of a noisy neighbor kind of issue. I can have a dedicated environment. So even kind of a classic 3-tiered application, I could do virtual share everything for the web tier. I could do virtual private for the application tier, and then I could go bare metal for the database tier. And so a much larger spectrum of applications, very data I/O intensive applications, can run on SoftLayer and have a much more consistent performance and cost characteristic than traditional cloud service providers provide. Now, that brings us to the whole aspect of what we did with Volt on SoftLayer. SoftLayer, we felt, was ideally suited for the fast data applications, and so we worked with the Volt team to optimize the VoltDB solution on the SoftLayer, taking advantage of the bare metal performance that we could provide. And going back to how Scott was talking about how the world fits between kind of fast data and big data, you see you can ingest data from a wide variety of sources, whether it's mobile devices, Internet of Things, embedded sensors, etc. And then you make it smart by being able to analyze it, enrich it, optimize the data. You can take action there in more of a real-time fashion, and then you can take that pre-processing data and put it back into data repositories. You can also put raw events back into data repositories. Those data repositories could be any kind of Hadoop-based analytics data lake and a set of analytic engines that are interacting with that repository of data that's typically SQL-based. It could be applications that you've written, like with the IBM Bluemix platform, where I'm using an out-of-the-box experience in terms of being able to have a fabric of services, including data services, and I want to be able to take that pre-processed data and incorporate that into some of the data services that are within Bluemix. Or it even could be our cloud and acquisition, our fully managed NoSQL database service, which is used quite heavily by the Internet of Things ecosystem. So this aspect of being able to have this fast data layer where you can do things in real time and then take the results of that, more intelligent information, and then store that back into a more persistence layer, really gives us kind of the best of both worlds. You can take real-time action. You can have better data going into your data repository, your big data repository, and then the analytic engines that are interacting with the big data repository have better data to more optimized data to act upon. So you kind of get the best of both in terms of being able to have real-time analytics as well as being able to maintain a batch analytics approach for things that batch makes perfect sense for. And so what I want to do now is turn it back over to Scott so he can take you through some of the benchmarking that we did on SoftLayer with Volt.
Yeah, thanks, Mac. It's funny, in the conversations that you and I have had, I don't think I ever mentioned to you that when we initially launched Volt, and this will be obviously interesting to the audience as well, when we initially were launching the company, the thought going around was that this is a high-performance compute system, and nobody would ever run it on the cloud. And the characteristics of the cloud wouldn't support that. And what we've learned, and I'm sure you guys have known for a while, is that the cloud is fully capable of doing that when designed properly. And that was one of the big surprises that we had as we started down this partnership with SoftLayer, was to really see the impact that we got out of a cloud that was designed around the capabilities to support both high-performance operations as well as the traditional cloud applications. So we did a bunch of benchmarks, as you would imagine as a database company often does. And one that we've kind of standardized around, and we do many, but the Yahoo, the YCSB, the Yahoo Cloud benchmark, which is a very popular benchmark for web serving type applications. And we've done some benchmarks on it in the past, and we have some great write-ups. And we were very proud of our results that we had on AWS that we published, I believe, a couple of months back now. And we started working with SoftLayer and really looking at what we can do when we I believe we put clients on one class of hardware, and we put the database on another class of hardware. And what we saw, as you can see in these graphs, is some pretty amazing results. We're running on only 12 nodes, so this is not a 1,000-node Volt cluster. This is only 12 nodes of a database system, and yet we're running over a million transactions a second for 3 nodes, and scaling all the way up to nearly 2.5 million transactions a second on the 12-node cluster. So what you see is not only a very linear growth in performance, as the red line indicates here, but you also see latencies that tend to be very predictable and very understandable to the application. So one of the things that we didn't delve into in the beginning, because we were talking more abstract, is the characteristic that a lot of these applications that are very fast oriented. So if I'm dealing with inbound sensors on smart grids or sensor readings on assets in mines or telco billing records, my applications tend to be very sensitive to latencies. And if you are in one of these noisy neighbor environments where one of the systems in your cluster or on your machine is spiky and taking a lot of resources at a particular time, you can see latency spikes that cause havoc in the application, and then the application programmers have to deal with an awful lot of fault tolerance and resistance, and how do they overcome those issues. But what we found in SoftLayer is a very consistent latency spectrum as we move through the performance all the way up to 12 nodes. So that linear scaling capability that you see in these graphs is a testament to both the processing power of these systems, but also the capability of the network. So in a distributed database system, as Volt is, it's high performance, distributed, and high throughput. All of a sudden, latencies and network performance become just as critical as the processor performance. So again, there's a tremendous amount of data that backs this. We have a white paper that's available that talks in depth about the tests that were done here. We've run YCSB on both these cloud platforms for you to compare and look at. We also have benchmarks on other platforms or other benchmarks, such as things that look like DPCC as well as key value workloads. Those are on the Volt website for you to explore as well. But these are the ones that we're most proud of at this point, which is this 2.4 million transactions a second on 12 nodes of Volt running in a SoftLayer infrastructure. That's the kind of applications that we're seeing much more frequently needing that type of throughput. And if you're not there today, I guarantee you that somebody in your business really has the objectives to get towards those kinds of numbers in the very near future. So with that, what I'd like to, we announced earlier today, and I'll mention here, is that VoltDB is available in the IBM Cloud Marketplace. So if you're interested in trying Volt out to see if it's appropriate for your workloads, and again, it's not appropriate for everything. One size doesn't fit all, but now knowing fast data applications that exist and big data, and if you have fast data applications, I would highly suggest taking a look at Volt and trying it on the IBM Marketplace. It's very simple to download and get to, and it's available as we speak now. So Peter, with that, I think we're going to wrap this part up and hand it over to you to go through some Q&A.
Yep, great. Thank you, Scott. Thank you, Matt. And for everybody that's attending, if you do have a question, we've got a few, but if you haven't typed in any yet, feel free. Use the chat window that's on your screen. And there were a couple of questions around that performance that Scott just walked through, and I think this is actually a little more of a question for Mac than Scott, because the performance difference between SoftLayer and AWS was huge. And the question's really around, is that, comparing like systems, and what's the advantage here of SoftLayer? I think maybe people don't fully realize that SoftLayer result here was run on bare metal servers versus the Amazon virtualized environment. But Mac, it's just a general question around kind of the value prop for SoftLayer and bare metal servers.
Yeah, so this is one of the main value propositions that SoftLayer had in market, and they were successfully leveraging prior to us acquiring them last year. 50 of the top 60 online gaming companies were hosted on SoftLayer. And if you think about what an online game is, you got a lot of high-definition video, a lot of data crunching on the back end, and you're delivering that to mobile devices. And so, as Scott mentioned, the network is a big part of any kind of distributed database model, but also this back-end systems being able to be dedicated. And that's really the key. I mean, you could have a dedicated private, and you would still have much better performance than you would get with a virtual share everything kind of model. So basically the intent of what SoftLayer provides is flexibility to pick an infrastructure that meets the needs of a particular application. And when you're talking about a fast data application, it's all around speed. You want to be able to have a consistent performance, consistent delivery of services, and being able to have a dedicated environment and being able to even use bare metal for that environment and still have the same kind of elasticity and consumability and cost characteristics that you can get with virtual. I mean, you can pay for bare metal servers by the hour now on SoftLayer, such that, if I have data-intensive workloads, I need to, and performance really matters, and performance equates to business dollars because I'm trying to get insight from that data so that I can act upon it. That really matters to the bottom line of what customers are asking for here, and that's one of the main value propositions of SoftLayer is the ability to have that dedicated environment for those kinds of workloads.
Yeah, no, that's terrific, and from VoltDB perspective, we're certainly seeing that, and it's shown in those results. We have a question here. We're talking about fast data and using VoltDB as kind of a fast operational database to support those kinds of applications. But the question is, does VoltDB work with some of these message queuing platforms that are out there? And Scott, I think you're best positioned to answer that.
Yep, that's a great question. Yep. Yeah, that's sort of one of the questions that we run into a lot, and it's actually less of a question these days and more of a statement that comes from customers, which is message queues. Kafka is a particular one we see a lot, but message queues are the way that we're moving data and shuttling data around applications within the organization. How does Volt fit into that? And we've adopted that model quite strongly and are firm believers that message queues are a great way of moving data between these two systems. So we see a lot of information coming in to Volt from message queues. So Volt will listen on a message queue for input and then do processing. And then we'll actually also have a lot of customers who are using the message queue on the outbound of Volt. So Volt could sit in the middle of a message queue, receiving data on one side and sending it out on the other, fully participating in that message queue. And with that, the other thing that I'd mention is that you start to look at how these pipelines are really architected and orchestrated, and having a queue as part of that. Queues have interesting characteristics. They provide persistence, but they don't really offer the things that you get out of the fast data database. So the two marry together in a quite strong way, and we've added a number of message queue systems that we support, including Kafka and RabbitMQ. I'll give you just one quick example, if we have just a moment, Peter, of one of the queuing systems that has really become quite popular with Volt. And that's this idea that traditional log files, the way we managed log files in the past is we'd store log files on remote machines. Think of them as a click stream. That's often a good example, so an Apache log file. We'd store that on a remote machine. We'd send it back into corporate. We'd run some process to aggregate all these things together, put them back down on disk as one file, then run them into something like Hadoop where you're going to do some aggregations to then put them back down on the file again so that now you can do your analytics and processing. Well, we have this really cool sample app that if you have this problem, I encourage you to go grab the sample app and use it. But it's very cool because all we had to do was change the log file, the Apache system, to say, don't write your logs to the disk, write the logs to Kafka. And now all of a sudden these logs are going in Kafka. Volt's ingesting the Kafka stream, so no change required there, very simple integration process. And now not only are you able to ingest these very simply, where you've gotten rid of all that file transfer and the aggregation and the cleaning and the data quality that you did before in batch processes, but now you can start to do things with that information much more in real time. You can use that to maybe make ad placement decisions or detect fraudulent activities or whatever. So you have a real-time capability, but you're also pre-aggregating. Right? Volt's really good at doing things like counting and aggregations and filtering and all the things you'd want that database to do. And you can do all that prior to it going off into your big data system, your Hadoop or your Netezza or your Blue or whatever. And it really simplifies that architecture a lot. And not only that, but it provides you additional capability. So that's a great example where a message queue sort of fits on the front and on the back of Volt and really, really simplifies an architecture.
Great. Thanks for that. There's actually a couple of questions around the benchmarks, what systems it was run on, et cetera. There's a lot of detail for that available on the VoltDB website, so I'd say we won't go into it here. But I think it's fair to point out that the servers used in each case were roughly comparable, and you can find the detail right off the VoltDB.
And one of the things I just interject there too on that is the fact that you have to remember this is a benchmark. When you start talking about real live systems, you're going to have lots of noisy neighbor kind of traffic that really wasn't factored into that apples to apples kind of benchmark. So we actually believe that in a real functioning system where you have a mixture of clients, some of which need to do fast data and some of which are doing completely different things, that you'll see an even bigger gap in the quality of experience and the consistency in terms of the performance that you can expect.
Yep, great point. Scott, this is a question for you and one we tend to get a lot. Given VoltDB is an in-memory database, how does the data persist? Is there the potential to lose data if you're not saving it on disk?
Yes, we do. We do get that question a lot. And I think it stems a bit from the old in-memory style databases that we've seen in the past where they didn't have persistence, and everybody always worried about how do you persist that data, what happens in a power outage, all the fears that are well justified. And I think the other piece of it is that or message queues also tend to have some level of persistence. So people are trying to figure out whether they actually need persistence in the fast data system or not, or they can get away with it just in the message queue. And so I'm going to address both points. The first is, how does Volt manage persistence? And we've spent a tremendous amount of our time and effort in building persistence into the database. And not just a surface level of persistence. Yes, of course, you can get snapshots and do backups and things like that. But we really look at and believe that Volt and any operational database that sits in this level of criticality within your infrastructure has to have certain characteristics. And we've as an industry, we've gotten down this battle of is something ACID or not, or consistent or not. I think all of that is academically interesting, but the reality is that you have to have these things because it makes your life easy. If you don't have these capabilities in your system when you're building the applications as the app developer, you're going to have to add those in later. So persistence is one of them. If you're going to try and manage persistence in your database tier by using other systems to do that, you've added a tremendous amount of work and complexity to your life. The database should do that. That's its job, as is managing other properties of consistency and all that stuff. But from a persistence perspective, Volt will manage persistence at a variable level that you choose. You can go from snapshots, as I already suggested, all the way down to every single event is synchronously logged to spinning media. So you can set Volt in a way that you can go from, it's just a little bit is enough, all the way down to every message is critical to my infrastructure. And I'll tell you, more and more people are looking at every event as critical. The days of people saying, I don't really care about most of this data, those are long gone. Every piece of data becomes very critical. And, I often hear people say, well, in a sensor app, it doesn't really matter if I lose this piece of, every fifth reading or something. I say, really? What if that's the one that would have triggered the system that said you're about to have a transformer explode? Right? That one probably shouldn't have been lost, but you don't know which it is. So every piece of data becomes important, and persistence becomes a huge part of that. And the other piece of it is don't build that complexity into other parts of the application. Actually do it in the database. The database should provide that for you.
Yeah, great. That's terrific. And you remind me, I did want to point out that in that benchmark result that VoltDB was running the benchmark with high availability enabled, which actually means it's extra work for the database to accomplish doing multiple writes during the benchmark. So that's just FYI. I think our last question here, the chart showed kind of the scalability of Volt on both platforms. How does Volt scale out in a cluster?
Yeah, we spent very little time talking about the architecture of Volt in this webcast intentionally, right? We have Mac and some great results in the cloud, but from an architectural perspective, I think the two products are also very well mated together. Volt is a scale-out database, so as you add additional nodes into a system, it grows, as you saw in the charts, very linearly. So you continue to add nodes, and you have, as you mentioned earlier, Peter, high availability and additional fault tolerance guarantees along with that. But by adding additional nodes in the network, the database seamlessly grows, both in terms of size as well as in terms of processing capability. And when you look at a system that is, high performance computing type operations, and you are scaled out in a network, all of a sudden all those things that we talked about where you aren't impacted by noisy neighbors, where you do have predictable latencies, those things become critical. So it scales out very well and horizontally, and it scales well beyond the 12 nodes that we tested here. But those things really are dependent on quality infrastructure behind it, and that's how these two products together are doing the kind of performance that we're seeing in these benchmarks.
Yeah, terrific. Thanks. So that was the last question. So in wrapping up, I'll just refer to the chart that I hope you can see. If you feel like trying out VoltDB, you can go to the VoltDB website, download it, or run it in the cloud. There's some educational resources that are available, both back up on the benchmark. There's information on fast and big data on the VoltDB website as well. And let me remind everybody, all the attendees, you will get a follow-up email from us. You'll get a link to the recording. You'll get a copy of the slides. We very much appreciate your attendance. And I want to thank Mac Devine for attending and telling us about SoftLayer and participating in the webinar with us, as well as Scott Jarr.
Yeah,
and
very
with
well.
that, we'll sign off. Thanks, Scott. Thanks, Mac, and thanks to our attendees. Goodbye.